So here this chord has a length of 20.5 centimeters. So from here, if you draw an altitude, this is going to split the chord into two equal parts. And let me just call that point X. So BX would be half of that, 10.25 centimeters. And same thing, AX would also be 10.25 centimeters. So this is actually an important step here. We know that CE has a length. So E is that intersection point. So that's 7 centimeters. This would be 4 because the radius is 11 centimeters. So here, if I connect that point B to the center O, I know what BX is, 10.25 centimeters. I know the radius here, which is OB, is 11. So I can figure out OX, this altitude, which would be 11 square minus 10.25 square. So I'll leave it in that form for now. Now, my interest is eventually to get to BE and AE. And if you look at this triangle here, that is OX. I just already have the value. And OE is 4 centimeters. So if I apply the Pythagorean theorem here, OX square plus XE square is equal to 4 square, this piece here. And OX square I already have. So that means XE square is 4 square minus 11 square plus 10.25 square. So if you compute the XE from this, it turns out nicely and comes out to exactly 0.25. So that piece is 0.25. That means BE, which would be to the center, that's 10.25 centimeters, half of the chord length, plus 0.25, that's 10.5 centimeters. And AE would be 10.25 centimeters minus 0.25 centimeters, that distance. And of course, this is drawn, exaggerated. The lengths are much shorter. So AE would be 10 centimeters. And they're looking for the difference between BE and AE, which is 0.5 centimeters. And that's the answer choice, C. So one key thing with any of these chord problems is always draw this altitude from the center. It's going to split into two equal parts. And then look for these right triangles and apply the Pythagorean theorem. That's the most common setup with these types of questions.